Okay, sorry about that. All right, so we decided we're going to do the dodecahedron next. This one's a little bit more challenging. What are the shapes on here?
Pentagons.
Okay. How do we find out what these interior angles are in a pentagon?
Well, they're going to all be the same.
That is true. They're going to be the same.
What are they? Well, maybe what are they going to add up to?
Ah, good question. What do angles in a pentagon add up to?
Well, in a triangle they add up to 180.
Yeah?
In a square they add up to 2 times 180.
All right.
So maybe in a pentagon they should add up to 3 times 180.
Okay. Well, that's a very good geometric observation. Why does that make sense? That
Well,
the angles in a pentagon would add up to 3 times 180?
Well,
Because chop it into 3 triangles.
Is that what you were going to say?
because we did the square and the tetrahedron. This has 4 sides and this has 3.
Okay. And then, so how does that help you with the pentagon?
Not really.
Okay. But this is interesting that we can divide it into 3 triangles and it adds up to 3 times 180.
Yeah.
Yeah? So, angles in a pentagon add up to 3 times 180. And then how many angles are there?
There are.
There's going to be 5.
5. So that each one is going to be 3 times 180 over 5.
Well, 180 over 5, that's 36.
Okay, 3 times 36.
And that would be 108.
108, very good. Okay, so each angle in a pentagon is 108. At every corner, how many angles are there at every corner?
3.
3.
This one, and then one.
Okay, so when we add them up, we get 3 times 108, which is?
Which is 324.
Then we have 360 minus 324.
360 minus 324.
36.
Okay, so now here I'm at 36. Now, how many corners are there on a dodecahedron?
Well, it looks like there's 5 on the top, 5 on the bottom.
and 10 in the middle.
Okay,
So
so,
20.
Yeah.
okay, so 360 times 20 is?
It's
Well,
300. It's
it's
720.
Hey,
why do we keep getting 720?
what is going on here?
Let's try do the octahedron.
Let's do the octahedron.
Maybe we'll get 720.
Okay. All right.
Well, this one at least looks a bit different since it looks like we have 4 angles per corner.
Okay. So what are each of those angles? Can you tell me?
Well, they are 60-degree angles.
Okay. So at every corner, we have 60-degree angles. How many?
And there's 4.
So what's 4 times 60?
It's 240.
And what's 360 minus 240?
It's 120.
Okay. 120. How many corners do we have?
We have 6. Hey,
120 times
720 again.
720.
Huh. And since we spent all this time building it, we may as well do the icosahedron too.
Let's see.
Oh, these angles are going to be 60-degree angles.
Then there's 5 per corner.
There's 5 per corner.
That would mean 300.
300.
We
So
get 60.
6.
so now when we go here, we get 60. How many corners are there on an icosahedron?
1, 2, 3, 4, 5, 6, and then we have that same on the bottom. We have 12,
Okay, so we have 12 times 60. Is that what we need to do?
which is 720.
Oh man, 720 every time. This is very interesting. So this is Descartes' theorem.
And it states that every solid is going to be 720.
Well, it's a little bit more precise than that. It says every solid that can be deformed into a sphere without breaking it,
Like if it were made out of clay. And you
like
could
if it were made out of clay. But the problem would be something like a donut has a hole in the middle, and you can't get rid of that hole. So we'll come back to that at the end. But it's really interesting. Any shape that can be deformed into a sphere, very good if it was made out of clay.
like any solid shape.
Yeah. This is going to become 720. So we're going to do another shape for part C where we don't know what the angles are. Okay?
Yeah.
Right?